Hello students, hope you all are stay safe and stay healthy. So in this corona holidays, I just want to share my knowledge about the subject of forthcoming semester. In specific, I just going to speak about vibrations. So generally, we have seen our day-to-day life that we have seen many earthquakes or design failures. Some sound causes the vibration. Very good example is musical instruments. Even our human body also got vibrated. Because of that, we are living by through the respiration, right? Okay. So in this session, I just want you to teach types of vibration and also some basics regarding the vibration. So today the contents we're going to see is what is vibration, what is the purpose of vibration study in engineering, what are the various types of vibrations and basic terms of vibrations. So generally, first of all, what is vibration? So when the body displaced by the application of external force, the internal forces in the form of elastic energy which brings the body to its original position, which means the body is displaced from the equilibrium position by applying some external force. Here, if the vibration happened in the certain object means that object is considered as an elastic member. The vibration takes place only due to the elastic force. Suppose if an object doesn't have any kind of elastic force means, if the object considered as a zero elastic force means, that body is considered as an rigid body and also it is a static object. So the vibration, you take the real time example, let you take the spring, consider spring without mass and consider the spring along with the mass. So the spring cannot compressed or tensed by due to without mass it cannot do anything, any actions. When I start to add the mass in the spring, because of the mass value, the spring gets displayed. You see in this image, you have seen this, the spring can expand, this distance of the spring can expand based upon the value of the mass. Suppose if I going to pull this mass downward or drag the mass downward, due to that the spring which opposes the drag force, that spring opposes the drag force is what we called elastic force. So vibration is nothing but it is simply is an oscillation. It is the oscillation takes place either by natural or either by forced. So we can see in detail in about the vibrations in the upcoming sessions. So what is the importance of vibration study in engineering? Since we have seen any buildings or any structures, because of simple earthquake, it faces the huge damage or it faces the huge loss. Example, Maulivakam building. So Maulivakam building is get collapsed not by earthquake, but like that buildings, even a small earthquake causes the huge buildings to fails in construction. So the unwanted vibration in engineering field, if I'm going to design any kind of object or if I'm going to design any machine component, we know we have to consider the parameters of vibratory aspects. Whether the machine component is able to withstand the vibration or not. Suppose if it able to withstand means what is the maximum level withstanding capacity that we have to find out. So the unwanted vibrations may cause loosening the parts from the machine. So the unwanted vibration means, for example, if you take your two-wheeler, when it move over the speed breaker frequently or for every 10 meters, because of the speed or because of the movement, that body experiences the loosening effect, which means the spare parts of the two-wheeler may get loosed because of vibrations. Hence, if we going to design the component, we need to consider the vibratory aspects. As a mechanical engineer, if you're going to design any kind of IC engine components or any machinery equipments, we need to consider those factors. The undesirable vibrations should be eliminated or reduced by through the following methods, such as removing external excitation, which means removing the unwanted motion or unwanted forces act over the body. And point number 2, using shock absorbers to reduce the vibration. And point number 3, using dynamic absorbers, which means vibrating arresters. And fourth one, resting the system over proper vibration isolators. Okay, so as we seen about the engineering aspects to design the component with free vibration, right? So here we're going to see there is a 3 types of vibration. Number 1, free, and number 2, forced vibration. Number 3 is damped vibration. Free vibration means by giving the initial force to start to vibrate. Example, if you take a simple pendulum, I simply holding the mass for a second at certain height. After releasing the pendulum, it starts to oscillate to and fro motion. So in this case, the initial potential energy value is very high, and when I release the pendulum, gradually the kinetic energy value is going to be hike and comes to equilibrium position. I am not giving any kind of resisting force or frictional force against the vibration. So the free vibration means for initial displacement it is happened by giving the force. For forced vibration, there is some frequent external force is acted over the component. Example, if you consider the electric bell, the bell, when I going to press the bell switch, it starts to ring continuously up to I take my finger from the bell switch. Hence, the continuous force act over the bell component because of some electric motive force. Therefore, this forced vibration is highly dangerous. So under the forced vibration that we have seen, there is uh, electric bells or any kind of forced vibration components, it faces the resonance. So first of all, what is my resonance means? The resonance is nothing but the external frequency of the body should match with internal frequency of the body. When the two frequencies get matched parallelly, it causes the huge loss to the concerned component. That is what we call forced vibration. And damped vibration means if I going to arrest the vibration or arrest the motion either by gradual way or either by critical or either by giving over. Damping means I just going to stop the vibration, but only the handling way is different, like forcing, like giving sudden force, like giving gradual force. I just simply going to arrest the vibration. So this is my final output of the damped vibration. So the types of free vibration that you have seen: longitudinal, transverse and torsional. For forced vibration we don't have any types in this portion, and damped vibration we have, there is depends upon type of motion arresting. It can be classified into under damping, over damping and critical damping. Next, so before enter into the vibration we need to know some basic aspects like periodic motion. Periodic motion means there is the continuation of this cycle for every period or for every duration. Time in terms of x-axis and in terms of vibration takes place in terms of frequencies. Generally, you should know the vibration can be predicted by through the frequency cycles. So the periodic motion is nothing but cycles plotted with respect to time. Time period means the number of cycles, time taken to complete one cycle is called time period. Frequency is nothing but number of cycles per unit time. Amplitude is nothing but the displacement of the curve or the displacement of vibrating body from its equilibrium position. And natural frequency means the frequency of the internal body or the natural frequency for every object will differs. For example, if you take stainless steel, the natural frequency will get varied. The natural frequency is varied, depends upon the type of mass or value of the mass. For example, if you take the 5 kg mass means it have different natural frequency. If you consider 2 kg stainless steel bell ring means it having different frequency. Therefore, the natural frequency can be differed from mass values. Okay, let me see in detail in the next further session. Then fundamental mode of vibration is nothing but is the mode having lowest natural frequency, which means almost the vibration comes to end or vibration cycle will comes to end. That is what we call fundamental mode of vibration. So let me see the simple harmonic motion. The vibration is based upon simple harmonic motion and it should obey the Hooke's law. So simple harmonic motion is nothing but it is to and fro motion. The amplitude value of positive and the amplitude value of negative cycle doesn't change. Let me see this video to understand the SHM simply. So in this video you have seen that the initial, I mean the displacement from the radius of the circle will traces the same value radius in the amplitude value. That is what you see, this distance, the distance between this point and center point will be equal to this distance cycle. So this is a very good example. The amplitude of simple harmonic motion will be same for both positive and negative cycles. Since I already told, vibration is based upon Hooke's law. Generally, Hooke's law is nothing but if you give any external force to the elastic member, or if you take example of spring, the spring gets either tensed or compressed due to the force. So because of the compression or tension, we can easily able to determine the spring stiffness value. Therefore, the equation of Hooke's law, F is equal to K into X. So the F is equal to K into X is nothing but K is the spring constant, or otherwise stiffness of the spring. X is nothing but displacement taken by the spring. Okay, so let's see the small video about understanding of Hooke's law.
Original shape as soon as the deforming force is removed. But what really happens? In a state of deformation, there is a restoring force generated inside the body resisting the deformation. Yes, a restoring force. When the body is in equilibrium, this restoring force is equal in magnitude to the deforming force and acts in opposite direction. And as soon as we remove the deforming force, this restoring force comes into play and restores the body to its original shape. Plastic deformations, on the other hand, are and which ones show plastic deformation? The applied force here is simply too much for the body to bear, and that results in permanent deformation. Now, which objects show elastic deformation and which ones show plastic deformations? Generally, all the objects show both types of deformations. Yes, for instance, if we just keep extending the spring forever, there will be a certain limit beyond which the length won't increase further. And if we try to apply more force, the spring may loosen and end up breaking. So the spring shows elastic deformation up to some extent, beyond which it results in plastic deformation.
So hope you understand about the elastic and plastic deformation. Okay, so let we come to the components of vibratory system. So generally, in order to stop the vibration, that we have to see about three kind of components in basic things, like first of all spring, second one mass, and third one damper. So in this diagram you have seen this spring without mass. So by adding mass, it takes the displacement value x. There is some resisting force which opposes the spring motion, and if you're going to pull the mass or drag the mass towards downward, it opposes the resisting force. That is what this displacement plus this displacement F into x plus y. This x plus y is nothing but displacement traveled by the spring. This is what we call stiffness of the spring. Okay, so now we wind up the session. Here the vibration is nothing but it is simply an oscillatory motion or to and fro motion. There are many different types of point number 2. Vibration is nothing but based upon forces or based upon type of force which act over the body. It can be classified into free, force, and damped. Free means initial force. Force remains giving the external influence force, which means continuous force. Damped means it can arrest the vibration either by gradual or sudden. And point number 3 to recall, vibration is based upon the principle of Hooke's law and simple harmonic motion. And the basic components of vibratory system is nothing but spring, mass, and damper. So, hope you understand about the basics of vibration, and let me see in detail one by one topic in the upcoming sessions. Thank you so much to listen patiently.